Hey everybody, my name is Jeff. I am a member of Google's Web Developer Relations team. I'm super happy to be here with everybody tonight. I'm happy to be here on the second anniversary of React NYC. That is for everybody who's watching the video later on. That's what's going on today. And I was going to put together some slides for this, and as I was working through the slides, more and more of what I was doing was just going to be like code samples and like trying out things in DevTools and seeing what worked and seeing what didn't work. So no slides, all web app and doing live demos and stuff like that. So we'll see how that goes. I'm going to say that I'm not a web developer. That's why things look like that when I put it together. I'm not really a React developer either, but I work with the React community a lot. And honestly, what I do is work with a lot of developers on tooling and then also kind of thinking about loading and speed and kind of what it means to ship modern web applications. And just make this a little bit bigger. So the idea for the talk, though, is kind of exploring what happens when you combine like modern loading best practices. So things like hashing your asset URLs as part of your build and aggressively caching that. Lazy loading some of your assets based on different routes, hooking into your router and doing that. Using service workers, which is something I work with a lot. And then doing that in the context of a single page application. So single page apps tend to stick around for a while. You might have your tab open for days, depending upon how popular the app is. And those apps tend not to really navigate from page to page. They can be loaded and just stay loaded, and definitely use the history API to kind of move around. And finally, just like think about what that means when you go through common deployment scenarios. So like you are probably making changes to your code all the time. You're pushing out updates. You're not like waiting until Friday, at 9 p.m. and only pushing out once a week, probably, depending upon what you're doing. And it just seems to me that taking all those three things together, maybe it doesn't apply to everybody here, all those three things, but if you do think about all those three things together, it kind of leads to some interesting and maybe non-intuitive gotchas. And I just want to walk people through that and think about how to work around some of those gotchas before you actually accidentally deploy something in production and some percentage of your users find that your web app is no longer working when they try to navigate to a new route and things like that. So my idea, first of all, everything's hosted on Glitch. Glitch is a really cool both online editor and also kind of environment where you can run Webpack and you have a container and you can do things on the command line, stuff like that. So you can follow along. That's this page right now, pwall.glitch.me. I'm going to go and edit my copy of that, but you could kind of like go and fork it and play around a bit. But I'm going to switch real quick to the actual code. This is going to be kind of different steps. The very first step, I wanted to simulate a really, again, I'm not a React programmer. I barely do anything approaching web development. So I thought, okay, let's have a really basic, maybe web app that has 3 routes. One of the things happens to also be 314, so it's Pi Day today. So one of the routes is going to just give us 1,000,000 digits of pi. One of the routes is going to be a simple home page. One of the routes is going to be an about page. And that might look like, let me just go here. I'm just going to go here and open up what it looks like. It is super basic. Yeah, pi. Nothing crazy. Okay, so what I wanted to point out though, first of all, this is the code that you might have for that sort of thing. So starting out with just static imports, no code splitting or anything like that. We have 3 components. They have our like pi component is really big, and our about component, our home component, that sort of thing, are a little bit smaller. We're just pulling those components in. We're running everything through Webpack. And what we're doing is we're getting something that we can see loading. So I'm going to pull up the network tab and use this a lot here. And let's just take a look what happens when you start interacting with this very basic version of our web app. So pump up this a little bit, pump up this a little bit. So one of the things you'll see right away is that you're pulling in 1.1 megabytes of JavaScript. as soon as you go just to the home route. I can tell you, not a knock on React or anything, most of that is taken up by the million digits of pi. But the thing is, you're not really looking at that right now. You can imagine this is a part of your web app that maybe a few users will go to, just in your own real world web app. Imagine that there are some bigger portions of your web app that not as many people go to. But with this kind of approach, you end up paying the cost of downloading all that JavaScript in order to render something that's not even on the screen right now. So honestly, that's not great. And I think a lot of people in the React community probably agree with that. And I know that the React team has done a lot to kind of make things better, along with various tooling teams like the Webpack community for doing alternative approaches to that. And it kind of gets to the second scenario, which is probably what you would want to do if you started out in that situation. And that is to, instead of load everything all at once, try to implement something called lazy loading. And lazy loading is the idea. Let me pull up the code for it as we go. So lazy loading is the idea of, instead of pulling in all of your components at once into one big bundle, using this special syntax that has kind of this dynamic import over here, and along with some metadata for Webpack to tell Webpack like what to call the JavaScript file. And we wrap this in this lazy. This lazy is provided by the React package. They also provide, I think this is all new as of React 16, something called the suspense component that can wrap your lazy loading and provide a fallback. And this is all kind of a way of splitting up, mixed together with this router that I'm using here, React router DOM, pretty standard. This all works together to only pull in the specific components that you need when you've actually navigated to a particular section of your web app. And if you take a look at the Webpack config that goes along with that, nothing really had to change over here. We have a file name, name.js. This is going to pull in and use the names that we provided as part of our import statement in the previous section. And I'm going to pull up code for this for a second. So if you just take a quick look at, here's it already built. We have a bunch of different routes now, route-specific JavaScript now. So, our app is what gets loaded unconditionally. It's not super small, but it's less than a megabyte. So that's good. And then you can see that our pi is like really, really big, and the other ones are pretty small. So in practice, if you actually visit, let's go to the second example right now, and you take a look at what is loaded, you'll see that we have, this is our HTML. This is our now smaller app.js bundle. And then we are loading dynamically. Maybe we can see this. You can kind of see flash for a second that text where it says I'm lazy loading. So that's the fallback from suspense. And it will pull in this home.js. So the cool thing though is that when I click on about, I now can see in the network panel, about.js gets pulled in. And that's also pretty small, so it's not too bad. I'm going to click on pi. This is going to pull in, and so we get trying to lazy load. And then we get a million digits of pi. I forget what the news was earlier today about something like 83 trillion digits of pi. Somebody just calculated. That would probably strain the Wi-Fi network here a bit. So I'm just limiting it to a million. And you can see it's still pretty big, and it takes a bit of time. But the important thing is people who do not actually navigate to that route don't pay the cost. And the way things are set up right now, if I were to reload the page, it would just go directly and pull in our pi.js. So some things to note, though. Every time I go to this page and I end up pulling in pi.js or any of the other files over again, it's re-downloading everything. So you're paying that 977 kilobytes on the wire cost every time you navigate there. And that's not great. It's at least not something that gets pulled in unconditionally, but ideally, what we'd like to do, and what modern build systems make it pretty easy to do, is to add some versioning information to each of the things that get pulled in. And then be able to say, this URL corresponds to a unique resource. I know it's safe to cache it, as long as possible, which is usually around a year. And you don't actually have to go to the server and re-download it when you request it again. And we could do that. We're already using Webpack, and Webpack makes it pretty easy. So I'm going to pull up let's take a look at the code for the third step here. And actually, one more thing that I wanted to point out. Let me go back to the second step, because I wanted to talk about changing things and just what that experience is. This probably is obvious, but it's going to motivate what we do right after. So right now, this is the about component version 1. If I'm going to go here, there's a shared about component. I say version 2. And then I go here and I say 222. We kick off another Webpack build. So it takes a little bit of time. I just want to point out that what it'll do is pull in. If I go here, it's version 1, and then I load it again, it's version 2. So it already had that loaded previously, version 1, but then when I navigate back, it's version 2. And it's still using the same about.js URL, but it now just happens to say version 2. Okay. So let's take a look at what happens when we actually want to add in that asset hashing and be able to kind of take advantage of long-lived HTTP caches. So nothing actually needs to change over here. This is all the same. We're still doing that dynamic import. We're still naming our Webpack chunks. But what we do want to do is just modify our Webpack config a little bit and add in this chunk hash over here. So we have the output file name is going to be the name, so either app or whatever the chunk name is, and then a unique hash that is specific to the contents of that file, and then .js. And that's going to be spit out for all of our components. So I'm going to pull up the third example right now. Let's take a look. Reload this again. And you can see I have a bunch of long hashes here now. So that all is working as expected. I have a Webpack build set up so that it all automatically inject the proper app JS version into the HTML that's generated, and it knows how to lazy load everything. So that all is cool. Even more importantly, if I go here and I go to Pi and I reload Pi, you can see, I have this URL. It's not going to change, and now I can load it safely from the disk cache. Somebody were to update Pi's value or something, then it would get reloaded. But we're not going to do that. What we might want to do, though, and this is a pretty common scenario, and we're getting into the things where you kind of have to start thinking about, okay, how do I have some potential failure scenarios to worry about, is update our about page. All right, so I'm going to load current version of our web app. So you can imagine in the scenario, you just have some users, they have your SPA open in a tab. You're now going in and making some crucial changes because, again, this is super straightforward. I'm just going to bump the version number. Say version 3. We're now in the third example. So let me kick off another Webpack build. And let that run. And what you're going to see in the output is that there are hashes assigned to all the files as before. And in particular, the about file has this hash, for a d, blah, 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 blah. So this is what's currently output. And by the way, as part of my Webpack build, and I think this is pretty common for a lot of scenarios, in the real world, I'm cleaning out everything that came before it. So all the old stuff that I had is gone. I just have this new kind of state of my application at this point in time. And my about component has that particular hash. So obviously the reason I'm talking about this is because this is a problem for any of your users who have your web app open, they click on About, and then it works because it was previously cached. So sorry about that. Let me do this in a incognito window. And let me bump this up to 4 and do another really quick rebuild. And this time it'll show what I meant. Okay. So you do have the advantage of the disk cache. Actually, for people who have previously been to that URL, the disk cache will satisfy that request. But for people who have not been, and at this point it should actually fail, hopefully, yes. Okay. So now the disk cache did not have anything for About with that particular hash that I was looking for. It has this new hash, which is not what the page is trying to load, and you get nothing on the screen. So your users would see nothing at this point. And this could honestly happen to anybody if you're just kind of following the basic like example of how you're loading in things like this. Fortunately though, like if you were to read through the docs for React and lazy loading and suspense and everything like that, right below it, they have some really good docs for something called an error boundary. And I believe that this is React team's recommended way of detecting when there's this type of failure in any type of, pretty much any type of failure. It's kind of like a try-catch block. But in particular, for our case, it could detect the failure to load things lazily. So that's super relevant to what we're doing right now. And the way you work with it is basically just to wrap whatever might be doing the lazy loading in a new, I call it lazy loading error boundary. Lazy loading error boundary looks like this. The important things are that it has to like implement get derived state from error, and then you can conditionally render different things depending upon whether the error, which is again basically a catch, was triggered or not. So over here, I'm still not going to be able to show anything really useful, but at least I'll be able to say, hey, something happened when we're lazy loading, and give a potential recovery scenario. And the recovery scenario in this case is just to reload the page and kind of get the latest like list of all the assets that are supposed to be there. So let's try to simulate that failure and see how the recovery works. Okay, so I have version 4. So over here, I'm going to do a build of and I'm going to also, let's do this straight in an incognito window. So it's in the middle of the build right now. Okay. Okay, so I have my page open. Right now, if I were to click on this About, and I'm not going to, it would load in version 4, but I'm going to update this to version 5, do one more build. So you imagine, again, you're updating your site. People have it open, and let's see what happens as soon as that build is done. And there we go. And click About. So we'll see the failure again, but this time, we actually are able to detect that, and we're saying lazy loading failed. Again, limit of my web design experience is putting buttons on pages that people could click. You could certainly imagine trying to present some sort of nice UX for your users in this case. I was kind of toying with like showing an example where you forcibly reloaded the page. Probably could get away with that, especially if you like try to protect against infinite reload loops, which I'm a little worried about. But basically, if you were to click on that, it will then just do a window location reload, and you'll now get working experience, which is great. But we go one step further. And what we're going to actually do in this particular case is bring in something which is really part of my day job, and that's service workers. So service workers, super, super quick, are kind of this way of putting in some JavaScript code that sits in between your browser and the network. And it can intercept all sorts of network requests, and it could basically respond in whatever way you want it to, including responding by taking some previously cached assets and using that to satisfy the network response. So that's actually perfect for what we're trying to do. We would like to be able to take a kind of a snapshot of all the assets that we have with all the versioning information at a given point in time. And that will be effectively installed when the user first visits the page. And that'll continue to be in use pretty much until like there's a newer version of the service worker in place. So let's see what that would look like and see what some of the controls might look like for letting the user know, hey, there's something newer to load. So I'm going to really quickly, so I'm probably running a little bit out of time, say over here, this is version 5. This one I'm definitely going to do in an incognito window because service workers have a lot of state that sticks around for a while. So starting in an incognito window is always my tip. But what you kind of see over here in this other panel in DevTools is now we have the service worker. This service worker is generated using a tool called Workbox, which I work on. So it's part of the Webpack build as a plugin. You can just drop in and you can take a look at cache storage right over here, which will show you all the stuff that it has in its cache. So this is really cool. We have all of our things cached right now. And if I were to go to the network and I were to reload, you would see that this all came from the service worker. By the way, this also means that this will all work offline because it's going to be loaded directly from the cache. I'm not even talking about offline stuff nowadays, right now at least. But that's something to keep in mind. But let me just show you what the scenario of updating looks like and then rebuilding. So I'm going to bump this up to version 6. And I'm going to rebuild over here. Okay, you will see some things spit out additionally as part of this build because it'll have like the service worker itself and like a list of all the assets that's pre-caching and stuff like that. I will also point out that, so yeah, we have our service worker file and stuff like that. I'll point out that if I were to click on About right now, this is like an older version because I hadn't triggered rebuild. So now it's on version 1, basically. So what's in the cache right now is version 1. If I go and reload the page, though, so first of all, though, that's pretty cool that version 1 is in the cache. So even though I've made changes, and in the other scenarios, that would result in a loading failure. Now you're actually showing something, which is cool. Like you're showing a given snapshot where all of your hashes are consistent and match up, and you don't have the loading failures. But the other thing that's going on is that I'm able to detect, using the Service Worker API, that there is a new version of all the assets that might be available. And that gets indicated over here by like saying there's a new service worker waiting to activate. What you can do over here is hook into those events and basically have something in your UI, hopefully something nicer than this button, that says, hey, click here to update, or some sort of like, there's a new version of so-and-so available, reload whenever you want. You get to customize whatever you want for that. Or alternatively, the next time somebody closes and revisits your site, everything will automatically be updated. But this is kind of like a way of detecting it while the user is still using your long-running app. If I were to click here, this basically what happened is that the new service worker took over and it forced a reload, and now you see version 6. So what I would say, because I'm pretty much out of time right now, is that what it looks like to actually add that in to your code, not too tough. We have this generate service worker plugin that I dropped in my Webpack config from the Workbox Webpack plugin package. This will basically pick up all of your assets as part of your build and automatically pre-cache them for you. You can include and exclude some stuff if you need to get more fine-grained. And the code that listened for like, hey, there's a new version of the service worker, and determined when it's going to show that message is over here. It uses what we call our Workbox window package, which is some code that you could run in your web app rather than like running in the service worker. This is running in the context of your web app, so I wrapped it probably pretty poorly in a React component, and I have some logic here for like, hey, show button if there's an update available, and then tell the service worker, hey, skip waiting and become active if somebody clicks on the button. So that's kind of all the scenarios I want to talk about. I have a bunch of links down here for like reading more about service workers and kind of best practices for code splitting and lazy loading. and caching and things like that. And I encourage folks to just think about how you're deploying code. Like if you realize, oh, I am hashing my assets like I'm supposed to, if I am lazy loading, like I'm supposed to, but I'm not really taking into account the fact that those lazy loads might fail, think about that. And hopefully, at least use React's error boundary, but, also potentially think about throwing a service worker in the mix and use that to address the situation. So play along, pawll.glitch.me, and you can try it out yourself. So cool. That's it for me. Thanks.